All right, if you've ever stared down a coding interview or a data structures exam, you know two names are pretty much guaranteed to pop up. Stacks, or Ewan, and queues, or Kuyruk. So today, we're going to break them down by tackling the exact kinds of problems you're going to see. And we're not starting with some boring definition. We're starting with a piece of tech you use every single day. So forget the dry, boring textbook stuff for a minute. Let's start with a little puzzle, something you probably do dozens of times a day without even thinking about it. Yeah, I'm talking about your web browser's back button. Have you ever really stopped to think about how it works? I mean, you click it, and boom, you're on the last page you visited. But how does it know? What's the secret logic running behind the scenes that keeps track of everything in perfect order? Well, the secret is actually super simple. It just remembers the very last page you went to and makes that the first one it shows you when you click back. See that? The last page in is the first page out. That little bit of logic, that's the whole key. And that powerful idea, that last in, first out logic, it's got a name. It's one of the most fundamental data structures in computer science, the stack, or as you'd say in Turkish, yiyun. It sounds simple, but trust me, it is the secret weapon for solving some really tricky problems. Let's see exactly how it works. So, the core rule is literally in the name. Last in, first out, or LIFO for short. The easiest way to picture this, just think about a stack of dinner plates, right? You wash a clean plate, you put it on top of the stack. When you need a plate, where do you take it from? The top. The last one you put on is always the first one you take off. That's a stack, simple as that. Now, in the world of code, we have some special words for this. When you add a plate to the stack, we call that a push. When you take the top plate off, that's a pop. And what if you just want to see what the top plate is without actually taking it? That's called a peek. So you push, you pop, and you peek. That's pretty much the whole game. And you will believe how often this simple idea shows up. That undo button you can't live without? That's a stack. The way your computer juggles function calls? That's the call stack. It's even at the heart of huge complex algorithms like depth-first search. Stacks are like the unsung heroes of programming, working behind the scenes everywhere. Okay, so a stack is perfect for backtracking, like with the browser button, but what about problems where the last one in should be the last one out? You know, situations that demand fairness, where it's all about who got there first. Just imagine this. You're in an office, and 5 different people all send a document to the printer at roughly the same time. How does the printer decide whose document to print first? It can't just be random chaos, right? And it would be totally unfair if the last person to hit print got their document first. That would be a nightmare. The solution here is a different kind of data structure, and it's called a queue, or kuyruk in Turkish. Its principle is the exact opposite of a stack, and it's just as easy to understand. First in, first out, or FIFO. It's all about fairness. It's literally like getting in line for a coffee. The first person in the line is the first person to get their drink. And just like with stacks, we've got special terms. When someone joins the back of the line, we call that NQ. When the person at the front of the line gets served and leaves, we DQ them. And if you just want to see who's next up, you can check the front. NQ at the back, DQ from the front. And again, just like stacks, queues are absolutely everywhere. They manage tasks in your computer's operating system, they handle data packets zipping across the internet, and they are the engine behind another huge search algorithm called breadth-first search. Super, super important. All right, so now we know our tools, the stack for last in, first out, and the queue for first in, first out. Let's put that knowledge to the test with a classic problem. I mean, this one shows up in job interviews and exams all the time. So here's the challenge. You get a string of characters like this. Your job is to figure out, are all the parentheses, brackets, and braces balanced correctly? Take a second and look at it. How would you even begin to solve this? You can't just count them, right? Because the order and the nesting matters. This is where a stack becomes a total superstar. The solution is actually really elegant. Here's how it works. You go through the expression one character at a time. Anytime you see an opening bracket, like a parentheses, brace, or bracket, you just push it onto a stack. Simple. Now, when you see a closing bracket, you pop an item from the stack and check if it's the matching opener. See? The last opening bracket we saw has to match the first closing bracket we find. It's the perfect job for LIFO. If you get to the very end and the stack is totally empty, boom, it's balanced. Okay, so this is the million-dollar question for any exam, right? When to use a stack and when to use a queue?
Well, it almost always boils down to one simple thing. What's the order you need to process your data in?
It really is all about the order. If your problem involved reversing things, or backtracking, or undoing an action, think of that undo button, you're almost certainly looking at a stack, a Yugen. But if your problem is about processing things in the exact order they showed up, like a to-do list or a print queue, that's a job for a queue, a QDIRC. And this table sums it all up perfectly. You can see the logic side by side, LIFO versus FIFO. But look closer at the operations. For a stack, a yawn, everything happens at one end, the top. But for a queue, a KURUK, it's a two-way street. You add to the rear and you remove from the front. That simple mechanical difference is what creates their totally unique behaviors. And here's something amazing that they both have in common. They are incredibly fast. Their main jobs, adding and removing things, happen in what's called O1, or constant time. Now, what does that actually mean? It means it doesn't matter if your stock has 10 items or 10 times million items. The time it takes to push or pop one thing is always the same. It's lightning fast. And that crazy efficiency is exactly why you see them everywhere in software. So, if you're going to remember just one thing from all this for your exam, let it be this. A stack is for backtracking. Think going down a maze and having to retrace your steps. A queue is for level-by-level processing. Think exploring every single room on one floor of a building before moving to the next floor. All right, to wrap things up, I want to leave you with a little brain teaser. Another classic interview question. We know a stack is LIFO and a queue is FIFO. They're opposites, right? But could you build a fully functional queue using only two stacks? Think about how you could use the LIFO behavior of two stacks to create the FIFO behavior of a queue. If you can crack that puzzle, you'll have a much, much deeper understanding of how these powerful tools really work.